David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Let's look at some other normal distributions. And really what this is that we're going to relax the requirement that we had with the standard normal distribution, where mu, the average, the mean, was 0 and standard deviation is 1. And we're going to look at other ones that have different values for the mean and different values for standard deviation. That's the only difference. All the work on the calculator is identical. So this shouldn't add significant wrinkles to your work. You just have to pay attention when you're entering your mu and your sigma. So notice how I put mu not equal to 0, sigma, squared sigma, not equal to 1. So now our notation, we lose the z. So the z was there for the standard normal distribution, and that implies mu is 0 and sigma is 1. So if we're not doing a standard normal distribution, we're back to our random variable x, n for normal distribution. Now this particular one has a mu or a mean of 10 and a sigma of 2. Remember, this is the variance, so I could write 4 there, but 2 gives you a feel for exactly what sigma is. And then, so here, my mu is 10 and my sigma is 2. So what I want you to try to do, maybe with a pencil so you can erase if you don't get it, is I want you to sketch this distribution, and in particular, I want you to label your horizontal axis with the standard deviations. Right, here we go. I put my mu, my mean at 10, that's at my peak, and then I'm just going out by standard deviations, but since standard deviation is 2, I went to 8, 6, and 4, and here I went to 12, 14, and 16. So that's essentially a sketch of this scenario. Let's do a problem with this scenario. So check this out. Here we go. What's the probability that random variable x is going to be less than 13? So you have all your variables, all the variables that you need. You've got your mu, you've got your sigma. Now you know that you need to be less than 13, so you're going to be able to figure out your upper and your lower bounds. Go ahead, put that in the calculator and come back. All right, so I get 0.933 when I put that in my calculator. Really straightforward. Actually, nothing really new there, except we're just not using 0 for our mean and 1 for our standard deviation. But otherwise than that, it's the same process. Now, the IB wants you to be able to do this process called standardizing your normal distribution. And that means there's a little arithmetic trick that you can do to turn this standard distribution into, this normal distribution into a standard normal distribution. So let's take a look at that. So really what we're going to do is we're going to convert this number that relates to this distribution, which has 10 as the average, to a number that would work the same as though 0 was our average and 1 was our standard deviation. So it's a pretty straightforward formula. This z value, right? Remember how we have x up here. We're not looking for z. So we have z here. It's just going to be x minus mu over sigma. So that would be the x here for what we're trying to find. X minus mu, there's our average, over sigma. In this case, that's 2. So I have 13 minus 10 over 2, which is 3/2, which is 1.5. So that becomes the z value that we're trying to compare with in our situation with the normal distribution. But now the z value can be used with the standard normal distribution calculation. So I want you to pause the video and write out that statement here, z equals, and write out your calculation for that. So here it is converted into notation for standard normal distribution. So variable z, random variable z, reserved for this situation where the mean is 0 and the standard deviation is 1. Now it's being asked us to find the probability that z, our random variable, is less than or equal to 1.5. So that's the z value we got here with the x minus mu over sigma. So now you can go ahead and put that in the calculator. If we do this all correctly, we should wind up with this same value, this same probability. Pause the video and come back. So as you just saw, I get the same result when I treat this as a standard normal distribution, once I've standardized my variable, my random variable x, to a comparable z value of 1.5. So obviously, not doing this step if you don't have to is better. Fewer chances for making mistakes, and it gets you through an assessment quicker. So fine. But our textbook says that the IB will also write a question sometimes that will require that you know how to do this. So they might just prompt you, what is the standardized random variable for this situation? And you're going to have to remember this is how you do that. Let's do a word problem. In fact, we're going to stay with this problem for the remainder of this video. So here is actually a situation from real life where you could use this technique to calculate a probability. And so here we're getting to that place where the rubber meets the road and we're coming back around and we're joining with life. And remember, in mathematics, really what probably happened is we had life first and they developed the mathematics to be able to explain and predict life because we're doing probabilities. That's about predictions. So here's our scenario. We have this chicken and it lays eggs. Eggs laid by a chicken have masses that follow a normal distribution. So they follow that bell-shaped curve with a mean of 55 grams. So the average is 55 grams and a standard deviation, a sigma, of 2.5 grams. Okay, so here we have our scenario. Here's our question. Find the probability that a single egg laid by the chicken has a mass greater than 59 grams. So you have enough information right now to pause the video, pull out your calculator, and do this calculation. All right, I did a few steps for you. I first put this problem, the whole thing, into our notation. So random variable x, remember it's a normal distribution, not a standard normal distribution. So we use x for that, and for normal distribution, our mean is 55, and our standard deviation is 2.5. Remember, this spot is for the variance, so I always have to put my squared there if I'm writing my standard deviation there. Okay, so that's a statement of our scenario. Now here's our prompt. Find the probability that random variable x is greater than 59. In other words, the next egg this chicken lays, what's the probability that it's going to be over 59 grams? If you haven't already done so, put that in your calculator and come on back. All right, so here's what I get. 0.0548, 3 sig figs. So if you didn't get this, stop right now and get back to your calculator and make sure that you can put in the parameters for this problem in there and do that calculation. Okay, so now I want you to do the same calc, but I want you to standardize the random variable x so that you can use a standard normal distribution calculation to find this value. So go ahead and pause the video, take that as far as you can, and see what you get. All right, I went ahead and did my standardization calculation and set up the problem. I didn't solve it yet. So I need a z so that I can use the standard normal distribution calculation. And my z is random variable x minus mu over sigma. So I plugged in my values there, and I got 1.6 for my z. So now I'm going to re-articulate the problem from here to here using the standard normal distribution notation. And so I have z, normal distribution, mu is 0, sigma is 1. So I'm looking for the probability that z is greater than 1.6. So now I can put that in my calculator and I should get this same answer. Pause the video, do that, and come back. And presto, I get the same answer, 0.0548. So that works. So you want to be able to do it both ways. All right, let's do one more problem here. What is the probability that the next egg laid is between 52 and 54 grams? We're in the same scenario. Pause the video, put this in your calculator, and come back and tell me what you got. Okay, last one, and I'll let you go. So here we are. Here's the prompt. Use standard normal distribution. So there's your hint. You need to show that you can standardize to get a z value so you can do this calculation for this scenario, but not using just a regular normal, but using the standard normal. So that's your prompt. It just said use standard normal distribution to calculate the probability that the next egg's mass is greater than 53 grams. So pause the video and do that and come back. All right, here's the answer. If you got 0.788, you're doing great. Good job. Here's how it works. The first thing I did was I found my z. This is the standardization process. So I just subtracted my random variable x by our mu divided by our sigma, and I get 0.8, negative 0.8. So now, restating the problem and the scenario, standard normal distribution variable z, normal distribution, meaning 0 mu, 1 sigma, and I'm asking for the probability that our z is greater than negative 0.8. So I put that in my calculator with the 0 and the 1 in the correct places, and I get 0.788. Now just for grins, just to check, I also did it the other way, where I put in all my values, and I do get the same number. So there you go. Have fun with the exercises. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.